Moving on, we have phenylamine in the beaker, sodium nitrite in another beaker, and is dissolved in water. And in the Erlenmeyer flask, we have a concentrated hydrochloric acid. Slowly begin in adding the cooled phenylamine to the concentrated hydrochloric acid. The reaction is exothermic, so to avoid producing fumes, both reagents were cooled in advance. So a precipitate is forming, so phenylamine is added again. Now we add phenylamine again. Now since all the phenylamine is added to the cooled hydrochloric acid, we move on to adding the cooled sodium nitrite in the flask. This needs to be added slowly, keeping the temperature below 5 degrees Celsius. As a product, benzene diazonium chloride is stable in the temperature. The equation above shows that concentrated hydrochloric acid and sodium nitrite react to form nitrous acid and is an unstable acid. To maintain the temperature below 5 degrees Celsius, we add more ice. We see the equation of phenylamine reacting to acid sodium nitrite and concentrated hydrochloric acid to form benzene diazonium chloride. The video is speeded up and more ice are added to maintain the temperature. It took 5 minutes for the whole sodium nitrite to be added to the flask. In this state, we have already a benzene diazonium chloride. Its salt exists as a colorless solid that is soluble in polar solvents. Now, as what I mentioned earlier, hydrolysis of diazonium salt is needed to be done to form a phenol.